Now let's see the concept of a subgraph. A subgraph of capital G is a graph capital H such that vertices of capital H is a subset of vertices of capital G, and edges of capital H is a subset of edges of capital G. The assignment of endpoints to edges in H is same as in G. So what they mean to say by this definition is, if we have a graph, we can get a subgraph either by deleting vertices or by deleting edges or by deleting both of them, but only thing is you are not supposed to add anything to it, right? And also every graph is a subgraph of itself, which means if you take this graph is a subgraph of itself, right? Or if you try removing a vertex, or if you try removing some edges, or if you try removing both of them, only thing is don't add anything which was not there in the original graph. So whatever graph you get as a result is going to be a subgraph. Got it? Okay. Now let's see this concept of induced subgraph. So what is an induced subgraph is, it is a subgraph. So in general, normal subgraphs can be obtained this way. Either you delete vertices or edges, or both of them, you are going to get a subgraph. But in case of induced subgraph, it is obtained only by deleting vertices. Okay, that is the difference between subgraph and a induced subgraph, and therefore an induced subgraph is also a subgraph, isn't it? See, in a subgraph you are going to delete either vertices or edges or both of them in order to get a new subgraph, right? Or now in this case, if you are going to remove only vertices, we call it as induced subgraph. So for this example, you just see this, we have 1 2 3 4 5 vertices in the original graph. Now if I delete one vertex and one more thing, whenever you delete a vertex, all the edges which are incident on it will be gone, right? So which means, see, so if you delete V, then 1 2 3, these three vertices will be gone, and you got this subgraph. Now this subgraph is called as induced subgraph, right? Why? Because we deleted a vertex. In case if you just delete one edge, let us say this edge is deleted, then what will you get? S you get here, U you get here, and then V you get here, and W you get here, T. Now this is not an induced subgraph, it is just a subgraph. Why? We are not deleting any vertex. Got it? So even if you delete all these three edges, let us say these two edges are also deleted, and you are letting this vertex be there, still then also it will not be an induced subgraph, right? So what is the induced subgraph? You have to delete the vertices and all the edges which are incident on that, right? That only is going to give you induced subgraph. Okay, and next concept is path. A path is a simple graph whose vertices can be ordered so that two vertices are adjacent if and only if they are consecutive in the list, which means if you can write like this, then that is called a path. So 1 2 3 4, two vertices are adjacent if they are consecutive in the list. So one is consecutive to 2 3 3 to 4, right? Now this is called as a path. So Pn is a path with n vertices. According to the definition, this one is called as a P4, right? So if you have 4 vertices in a path, then that is called as P4. And then you can find out whether a graph is having a subgraph which is a path. Now in this case, if you look at this graph, it is having a subgraph which is a path. So what is subgraph? 4 1 3 2, which means if you delete this edge and this edge, then you are going to get a subgraph which is a path, right? Now this particular graph is set to contain P4. Why? It is having 4 vertices in a path. Got it? So this graph has P4 as the subgraph. Okay, so these properties will be used later. Okay. Now let's see a cycle. This is the definition of the cycle. Cycle is a graph with an equal number of vertices and edges whose vertices can be placed around a circle so that two vertices are adjacent if and only if they appear consecutively along the circle. So what they mean to say is, if you can have vertices like this, then it is a cycle, right? Now 1 2 and 3. Now if you observe it, they are as if they are placed along a circle in such a way that two vertices are adjacent only when they are consecutive, right? So we are putting all the vertices on a, or you can take a circle and you can see this, right? Let us say this is a circle, right? Now what they mean to say is you should be able to place the vertices along the circle like this, right? And two vertices are adjacent when they are consecutive, right? So in this case it is going to be 1, 2 and 3, right? So which is nothing but there is a edge between these two, edge between these two and edge between these two. That is called as a cycle, right? Now if you want to see a cycle with 4 vertices, there is a cycle with 4 vertices, isn't it? Cycle with 5 vertices, like that, okay? So now what they are saying is one more property is in a cycle the number of vertices and edges are equal. So which means if you have 3 vertices then there are 3 edges, right? And also if you observe it, the degree of every node in a cycle is going to be 2. The degree of every vertex in this cycle, see, degree of this one is 2, degree of this one is 2, degree of this one is 2, right? So and also they are saying that number of vertices is equal to the number of edges, okay, fine. And now, yeah, so if you observe this graph, this example, now this graph is having a subgraph. If I delete this 6, this graph is having a subgraph which is a cycle. So you can say that it is a C5. See, if you have a graph which is having three vertices, which is a cycle graph, then we can call it as C3, and this one is called as C4. This one can be called as C5, right? Similarly, now if you see this graph, if I take a subgraph by deleting this vertex 6, then I am going to get this, right? Now this entire graph can be written in form of that cycle. See this, take this edge and just tilt it over like this, then what do you get? I'll get 2 here, and 2 will be adjacent to 3, and 3 will be adjacent to 5, and 5 will be adjacent to 4. And now if I tilt it this way, so I get 4 will be adjacent to 1, and 1 and 2 are anyways adjacent, right? Now we see that it is a C5. Therefore this graph is said to contain C5 in it, or C5 is a subgraph of this. Now what about the relationship between a path and a cycle? So a path, if there is a path, there need not be a cycle, but if there is a cycle, I can remove one of the edges and I can make it a path, right? Now this is P5, got it? So which means if there is a cycle, I can get a path, but if there is a path, I may not get a cycle. Got it? Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries, for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have, you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.